Hello guys, welcome back to my video. This week, I'm going to talk about integer multiplication and division by the meaningful instruction. There are also two videos for this week. In this first video, I will cover the integer multiplication, and in the second video, I will talk about integer division. And this is the schedule for this week. I will go through question 9 to question 16 of pretest. And you will do homework 9 and reading assignment 9 as your weekly work, okay? And some of you have turned in the homework A already. And I think most of you guys provide a good understanding of using the methods, which is very good. I think I will first score your homework A and homework 9 so that you can review them and to see if you still have any question before you take post-test on April 27th. Okay, and yeah, please remember to review your homework so that you can get a better score of the post-test. And I will score your homework 6 and homework 7 after I finish scoring your homework 8 and homework 9. So if you see your score of homework 8 and homework 9 first, rather than the homework 6 and homework 7 on the D2L, please don't worry. And this is 3 methods that I have talked about last week, right? And pattern model and the charge field model can be used for multiplication and division, but the number line model can only be used for multiplication. Okay, so let's move to start from the question 9, right? So all the other number questions are testing your procedural knowledge, right? So for 4 times -2, I think it's just like I add -2 for 4 times. So the answer is -8, okay? And the question 10, it is a conceptual knowledge question, right? So here is a quick feedback about your homework 8, especially for conceptual knowledge question. When you answer any conceptual knowledge question, please don't just drawing the method. You will have to explain how you use the method in the rule to use the method, right? And especially you have to explain them by using a complete sentence for receiving 4 points. Just like the question here, okay, imagine you are a teacher, right? And when you teach kids math, you have to explain how you solve the problem to kids instead of only drawing the method on a whiteboard, right? So make sure that you provide as much as detail that you can, right? So so that you can get a nice score than you did in the homework, okay? All right, let's start from the pattern model this time, right? Because the pattern model is the simplest model in the meaningful instruction, okay? And also, the rule to use the pattern model is the same as the rule in the addition and subtraction. I mean, the rule to apply to the multiplication here is the same as applied to the addition and the subtraction. So I start from pattern model. However, for number line model and the charge field model, there are some newer rules to apply for in order to use to the multiplication. So I start from a pattern model, and here assume that kids know how to operate positive times the positive, but don't know how to operate the positive times the negative, right? So we knew 4 times 2 is 8, and 4 times 1 is 4, and 4 times 0 is 0. And here we found a pattern that is when every time multiplier decrease by 1, multiplier decrease by 1, the product will decrease by 4, okay? So according to this pattern, we know that 4 times -1, so again, when the multiplier decrease by 1, right, the product will decrease by 4. So that is 0 minus 4, right? The answer will be -4. Okay, and so back to our question. 4 times -2. 4 times -2. Okay, so 4 times -2, the multiplier here decreased by 1, right? So the product will be -4 decreased by 4. So that will be -4 minus -4. The product will be -8. So the answer is -8 for this question, right? So still pretty simple, as the same as addition and subtraction by this model, right? Okay, so let's move on to the number line model. Okay, so the rule of number line model here for the multiplication is quite different from the addition and subtraction. So in order to make sure you can be familiar with the newer rule, I will first go through below these 4 example questions so that you can understand how these 3 new rules work, and then we will move on to the question 10. Okay. All right. So basically, for the number line model, when we're using the multiplication, we apply time. We apply time into the model. Okay. So let's quick read these couple rules here. Okay. So the car now is at 0. Now the car is at 0. Okay. The positive sign that comes with multiplication represent the car face to the east. Negative sign represent that car face to the west. Okay. And the positive sign that comes with a multiplier represent the time in the future. And negative sign that means in the past. Okay, so right now I use this example to explain of these rules. 2 times 2. Okay, so the multiplication here is positive 2. Positive 2 means the car moved toward east by 2 miles per hour. Positive 2 means the car is faced to the east side and will move 2 miles per hour. Okay. And multiplier here is positive 2. So here that means in the future, right? Positive means in the future. So the 2 means 2 hours. So 2 hours later from now, that means the future. Okay, that means in the future. So what we're gonna do here, positive 2 times positive 2, that means the car moved to the east, and 1 hour later, the car will be at position 2, right? And the second hour later, the car will be at position 4. And this position where the car stopped at will be the final answer, right? So this is where the car is 2 hours later from now. So the answer will be 4. So back to the earlier, I say that in the number line model, when we apply to a multiplication, we use a lot about time, the timing concept for helping me to understand those different signs, the meaning, okay? So let's see another example here. When 2 times -2, so the car, the same. The car right now is at 0. The car right now is at 0, okay? And the multiplicand is +2. That means the car will face to the east, and the car basically moved to the east by the 2 miles per hour, okay? And multiplier here is -2. And -2, that means in the past, okay? So that -2 here will be 2 hours ago in the past, all right? So let's see, an hour ago, the car was at -2 position. And 2 hours ago, the car was at -4 position. So this is where the car was 2 hours ago, -4, okay? All right, let's see next example. So in this example, is -2 times 2, all right? So -2 times -2, this time, all right, so the car will start at, the car right now is at 0, okay? This is rule 1. And the -2 this time, multiplicand this time is -2. That means the car will face to the west, So I will have to switch my car to face to the west. And -2, right? So the car will face to the west by 2 miles per hour. The car will move to the west by 2 miles per hour. And multiply here is +2. That means in the future. So 2 hours later from now, okay? So 2 hours later from now, the car, okay, we start from the first hour later, the car will be at -2 position. And 2 hours later, the car will stop at -4 position, right? So this is where the car is 2 hours later from now, which is -4, okay? All right, so here we see the last example question. -2 times -2. The multiplicand, right, this time is -2. So the car will be the same that face toward the west. So that's the last question. So I have to switch my car to the west, right? And the multiply this time is -2. That means -2, that means 2 hours ago, okay? So 1 hour ago, the car was at +2 position. And 2 hours ago, the car was at +4 position. So this is where the car was 2 hours ago, right? Okay, so this is all the 4 different type of example question, and so that you can see in a different kind of situation how we apply these rules for the multiplication question. All right, and if you still feel confused about rules that I mentioned here, you can review my PowerPoint again. And when you review my PowerPoint, please download my PowerPoint and use your device to open it. Please don't play the my PowerPoint on the D2L directly, because on the D2L, some of the animation that I made for this PowerPoint cannot play properly. So as long as you download my PowerPoint, everything will be work, okay? Okay, so let's move on to question 10. In the question 10, we use the number line model. So the car right now is at 0. This is the first rule, all right? And the multiplication here is +4. That means the car is faced toward east and will move 4 miles per hour, okay? And multiplier right now is -2. -2, that means 2 hours ago, right? So 1 hour ago, the car was at a -4 position. And 2 hours ago, the car was at a -8 position. So this is where the car was 2 hours ago. And the answer is -8. Okay? All right, let's move to the charge field model. So like number line model, there are some different rules from addition. There are some different rules from addition and subtraction. This page, I show the general rule for all the algorithm. And next page, I will show a specific rule for multiplication only. Okay, so the general rule: positron represent +1, and one neutron here represent -1, right? So in the field, so the invisible pair rule still can be applied in this situation. I mean, into the every different type of situation like addition, subtraction, multiplication, and division. So here is a general rule for the charge field model, and we are going to see what's the special rules for multiplication only. Okay, so here are the rules that only for multiplication. Okay, so the positive sign that come with multiplication represent add something into a field, and the negative sign that come with multiplication represent take something away from a field. Okay, so here is an example. So the multiplication here is +3, right? So that means add 3, and the times sign here means group of. The times sign means group of. So here we have add 3 groups of, and the multiplier is -2. That would be the multiplier, the third rules here. Multiplier represents the amount of the positrons or neutrons. So the multiplier here right now is -2, right? So that means 2 neutrons here, okay? So basically this equation, after we use these 3 rules, this equation will be right as add 3 groups of 2 neutrons, okay? So let's see how we use in question 10, how we use this charge model in question 10, okay? So we start from a neutral field, nothing in the field, right? And the multiplication here is +4. That means add 4. And times sign here means groups of. So I add 4 group of, multiplier here is -2, right? So that would be 2 neutrons. So I add 4 groups of 2 neutrons, right? Add 4 groups of 2 neutrons into a field. So the field right now we have totally 8 neutrons in the field. So the answer will be -8. Okay. All right. So let's see question 11. So question 11 is procedural knowledge question. So here's my example answer. You can see this you can see this answer by download my PowerPoint. Okay, this answer is just for your information. You don't have to follow by my sentence here. You can use your own way to explain your positional knowledge for this question. Okay, and question 12 is a conceptual knowledge again. So in this kind of question, we will start to apply the concept about the negative times the negative is positive, right? So we will use those three methods to well explain why negative times the negative is a positive. Okay. So the same, we start from a pattern model because it's the simplest model. So we knew that students know how to operate positive times the negative, right? But they don't know how to operate negative times the negative. So we know -4 times 2 is -8, right? So -4 times -4 times 1 is -4. -4 times 0 is 0. And the pattern here we found is whenever the multiplier decreases by 1, the product is increasing by 4. The product increases by 4, okay? So based on this pattern, -4 times -1. So when the multiplier decreases by 1, the product will increases by 4, right? So 0 add 4 is 4, right? So back to the question. Our question is -4 times -2. -4 times -2. So same, multiplier decrease by 1, the product will increase by 4. So 4 add 4 is 8. The product of this equation is 8. Okay. Okay. Let's move on to number line model. So the same. The car right now is at 0, right? This is the first rule. The car right now is at 0. The multiplicand right now is -4, right? That means the car will move face toward west. So I have to switch my car toward west, okay? So -4 means the car will move to the west by 4 miles per hour. And multiplier here is -2. That means 2 hours ago, right? So 2 hours ago, 1 hour ago, the car was at position 4. And 2 hours ago, the car was at +8. And this is where the car was 2 hours ago. And the +8 is the final answer. Okay. in the charge field model. The charge field model. So same, we start from neutral field. We start from neutral field. And multiplication here is -4, right? That means we take away in the four groups of multiplier here is -2. So that means 2 neutrons, right? So when we put this equation into the meaning by this way, we take away 4 groups of 2 neutrons from field. We take away 4 groups of 2 neutrons from field. Okay. However, you see that we don't have anything to take away, right? So here we can apply the invisible pair rule here. We can apply the invisible pair here, okay? So because we have to take away 4 groups of 2 neutrons, so that means I will need at least 8 neutrons in the field, right? So that will be, say, I will need 8 invisible pair in the field. I will need 8 invisible pairs in the field like this, okay? And again, the invisible pair won't change the electric character of the field, okay? So no matter how many invisible pair you use in the field, it won't make any change to the original field, okay? So right now, it's about time to take away 4 groups of 2 neutrons, okay? So we take away 4 groups of 2 neutrons. Right. So how many positrons here left in the field right now? There are 8 positrons left in the field right now, right? Yeah, in the field right now, right? So the answer will be positive A. The answer will be positive A. Okay? So I will stop here, and this is the content for the multiplication. I will see you in the next video for the division. All right, see you.